Electric current is the rate of flow of electric charges through a conductor. It represents the amount of charge flowing across a conductor per unit time. In metallic wires, electrons flow, but the direction of electric current is opposite to the electron flow. This is because it's based on the conventional direction of positive charge flow. Electric current is calculated as the net charge flowing divided by time. The unit of measurement is the ampere, which is 1 coulomb of charge per second. Smaller units include the milliampere and microampere. To measure electric current, an ammeter is used, connected in series with the circuit. Electric potential difference is the work done to move a unit charge from one point to another. It's the driving force that sets charges in motion. The formula is V equals W over Q, where V is potential difference, W is work done, and Q is charge. The SI unit is the volt, named after Alessandro Volta. 1 volt is the potential difference when 1 joule of work moves 1 coulomb of charge. A voltmeter measures potential difference and is connected in parallel. The source of potential difference is often a battery or cell. It generates potential difference through chemical action and maintains current by expending stored chemical energy. A circuit diagram is a schematic representation of an electric circuit. It uses standardized symbols for components. An electric cell is represented by a long and short line. A battery is shown by multiple cell symbols. A plug key or switch has different symbols for open and closed positions. An open switch is an open gap with a line, while a closed switch is a closed line. Wires joined together are shown as a dot junction. When wires cross without joining, the lines simply cross without a dot. Each component has its own symbol, such as a circle with an X for a bulb, a rectangle for a resistor, and a rectangle with an arrow for a variable resistance. An ammeter is a circle with an A, and a voltmeter is a circle with a V. Ohm's law states that voltage is directly proportional to current if the temperature stays constant. This is expressed as V equals IR, where R is the resistance. Resistance is a conductor's ability to resist charge flow, measured in ohms. The formula for resistance is R equals V divided by I. For example, 1 volt and 1 amp means 1 ohm resistance. Ohm's law also shows current is inversely proportional to resistance, as I equals V divided by R. There are components like variable resistances to regulate current. A rheostat is a device that changes circuit resistance, controlling current flow. The resistance of a metallic conductor depends on its length and cross-sectional area. The longer it is, the more resistance it has. The larger the cross-sectional area, the less resistance there is. The material itself also affects resistance, with different materials having different resistivities. Resistance is proportional to length divided by cross-sectional area. This is expressed as R equals ρ times length divided by area, where ρ is the material's electrical resistivity. Resistivity is a material's property that opposes current flow, measured in ohm meters. Metals have low resistivity, while insulators have high resistivity. Examples include silver, copper, and aluminum, with resistivities of 1.6, 1.62, and 2.63 times 10 to the minus 8 ohm meters, respectively. Resistors connected end-to-end are in series, forming a single path for current flow. The same current flows through each resistor, and the total potential difference is the sum of the individual potential differences. The equivalent resistance in series is found by adding the individual resistances. Resistors connected between the same 2 points are in parallel, creating multiple paths for current flow. The potential difference is the same across each resistor, and the total current is the sum of the individual branch currents. The equivalent resistance in parallel is found by taking the reciprocal of the sum of the reciprocals of the individual resistances. In series circuits, the current is constant, voltage divides, and one failed component breaks the circuit. In parallel circuits, current divides, voltage is the same, and other components continue working if one fails. Total resistance in series increases with added resistors, but decreases in parallel circuits. Heating effect is the conversion of electrical energy into heat energy. This happens when current flows through a resistive conductor. The heat produced can be calculated using Joule's law of heating. The law states that heat is equal to voltage multiplied by current multiplied by time. Heat is also equal to current squared multiplied by resistance multiplied by time. The heat produced is directly proportional to the square of the current, resistance, and time. This principle is used in many appliances, including irons, toasters, and bulbs. Electric bulbs produce light when the filament heats up, but most of the power is lost as heat. Electric power is the rate at which electrical energy is consumed or delivered. It represents the rate of doing work or consumption of energy. The formula for electric power is P equals V. Alternatively, it can be calculated as P equals 1 squared R or V squared over R. The unit of measurement for electric power is the watt, symbolized as W. 1 watt is the power consumed when 1 ampere flows at 1 volt. Larger units include the kilowatt, which is 1,000 watts. The kilowatt hour is a unit of energy consumption equal to 3.6 million joules. Electric power is related to energy and resistance in a circuit. The key formulas are power equals V6, energy equals power times time, and resistance equals voltage over current. Electric current is defined as I equals Q over T. Potential difference is V equals W over Q. Ohm's law states V equals IR. Resistance is R equals V over I, and current is I equals V over R. The resistance formula is R equals RL over A. For resistors in series, Rs equals R1 plus R2 plus R3. For resistors in parallel, 1 over Rp equals 1 over R1 plus 1 over R2 plus 1 over R3. Heat produced can be calculated using H equals VIT or H equals I2 RT. Electric power is given by P equals VI, P equals V6, P equals I2 RT, or P equals V2 over R. Ampere is the unit of electric current, which is 1 coulomb per second. Electric current flows through a circuit, a closed path. Conventional current is opposite to electron flow. The coulomb is the unit of electric charge. Electric current is the rate of flow of electric charges. A fuse breaks a circuit during excessive current. Joule's law states that heat produced is proportional to current squared, resistance, and time. The ohm is the unit of resistance. Components can be connected in series or parallel. Potential difference is work done per unit charge. A voltmeter measures potential difference and is connected in parallel. The volt is the unit of potential difference, and the watt is the unit of electric power. Materials can be classified into conductors, insulators, and semiconductors. Conductors have low resistivity, allowing electrons to flow easily. Insulators have high resistivity, resisting electron flow. The choice of material depends on the application. Electric bulb filaments are made of tungsten due to its high melting point. Heating elements are made of alloys like nichrome, which have high resistivity and don't oxidize at high temperatures. Copper and aluminum are used for electrical transmission due to their low resistivity. Fuse wires are made of materials like aluminum, copper, iron, or lead, chosen for their melting points. In circuit design, parallel arrangements are preferred for domestic circuits, allowing each appliance to operate at the same voltage. Fuses are positioned in series with the device to provide protection.